All right. So we have been talking already about using lambda expression with string last time. Strings. This is what we concluded our last lecture with. Okay. So now we're going to move back to again comparators and filters. We're going to revisit something that we already went through not so long ago, actually a few weeks ago, when we talked about sorting in the Java framework collections. Okay, but we're going to revisit it with the lambda expression source pretty much. So let's take an example as usual that should look familiar. This is almost our class employee. Okay, that could be our class employee. So we have a class person. The only thing that really matters to us is that we have different ways that we are going to want to sort the class person potentially. Okay, so we have a name. We could have a first name, last name, doesn't matter. We have age. Both of these are fields, private final fields, okay, of different data types. We have a constructor right here. Constructor doesn't do anything fancy. Then we have a get name, get age that are just accessors for the fields, so nothing really complicated there either. Then we have an age difference method, and that we're going to use again for sorting, for min maxing, in a list. So the way that age difference works, it's really giving us a way to compare individual, okay? Even though it looks like we are just computing the age difference, but the age difference can be positive, negative, or null, okay, 0. So you can see the analogy here with the comparable interface and the comparator objects, okay? So age difference just takes another object of class person as parameter, and we just return the difference between our field age and the other object's field age, okay? And then we have a little toString implementation here, just to make things nice and easy to read on the console. We just display our name, dash, and the age. Okay, we have only two fields to worry about here. So quick run through of the old news. How do we make this person object sortable? Well, one of the possibilities to implement the comparable interface, which boils down to providing a compare_to method. So let's do that real quick. So here's our class person, implements comparable of person, so we change that. Dot, dot, dot means everything that was there on the previous slide is still there. And then we have 1, 2, 3 method that we add, okay? So we already took care of toString. toString is one of the methods that people recommend you implement when you want to play with the Java collection framework with your own class. Well, here are 3 others that are really high ranking on the list of recommended method. The hash code, that's going to allow us to tell if objects are the same. The compare_to, that's going to just allow us to compare two objects to sort them. So in this case here, we just delegate the call to compare_to between two person objects to actually, comparing the names. So we don't even care about the age as a first draft. And then we have the equals method at the bottom that does exactly what you think it would do. And we made sure actually that the equals and compare_to are semantically compatible. Okay? So nothing new there. Moving on. Now we are going to use this. So again, we have done that in the past already. Let's say that I have an array peoples of person objects, and I create it on the fly with the block initializer syntax. Create 2 person objects, one for John, Jane, and Jack. Then I put that in a list, and then I sort that list and I display on the screen. Okay, nothing again that we haven't done previously. So we are here at the same point we were before. Okay, so now the idea is how do we refactor this to benefit from actually lambda expression, potentially streams, things of that nature. Okay, so the best way to show the benefit is to say, well, now I want several comparison factors. Okay, and we've done that in the past. In the past, when we hit that new requirement, what we had to do is switch from implementing the comparable interface to using comparator objects. So we could pass those comparator objects to the sort static method of the Java collection framework and have it actually sort our list of people, friend, persons, whatever, with different criteria. Okay, we're going to do something sensibly similar here, but we are going to use, of course, lambda. All right, so here's our list of person. Nothing changed this, okay? I still use a release, transform it into a list of person. I think I changed the name there, but that doesn't really matter, okay? And then what we're going to do is we're going to first get out of the way a quick print people method. That's going to just allow us to display everything that is in such a list, all right? So we take as parameter a final string message, and it's just pretty printing, okay? It's just aesthetic. When I display my list of people, I want to be able to say, hey, this is the original list, and then display the list. Or I want to say, this is a list after a transformation. Here we go, here's my list, okay? So that's what this message is there for, and as you can see, all I do with it is just feed it to a system.out.println, okay? Second parameter, final list of person people. Okay, I just use the for each method. This is not the for each method from the stream classes, okay? It's just a for each method from the Java collection framework. I just call it on the list of person, and for each element in the list of person, I system.out.println using a nice little method reference here. So we have a list, we have a way to display that list. Okay, now let's work on trying to sort that list. So we are going to define the equivalent of, well, no, not yet the equivalent. Well, yes, we are going to define on the fly the equivalent of a comparator object here using a lambda. The lambda is in red, okay? But we are going to use a stream approach to generate a list sorted in ascending age. So here's our resulting list, the list of person ascending age. That's what we are going to produce. To produce that, we start with people, which is our list, our unsorted list. We generate a stream out of it. On that stream, we call the sorted intermediary operation. Sorted intermediary operation takes a lambda expression as parameter. Guess what? That lambda expression is our comparator. Okay, it acts exactly from a semantic point of view as our comparator objects. Okay, and then once we are done, we collect the result, and we went from a collection to a stream, did something on the stream. Now we shove it back into a collection so that we can have a final, data set at the end. So collect to list, okay? So if you don't have the proper import here, it's going to be collectors.toList. Okay, this is a method from the collectors class, a static method from the collectors class. And then we can display, okay, this is a list of people sorted in ascending order by age. So how do we specify we want it to sort by age? It's right here in the lambda. So the lambda takes two parameters. The sorted intermediary operation in streams takes a by function as parameter, sorry. So a by function means just that it's going to take two parameters. Until now, most of the lambda that we have been dealing with had one parameter, right? So here, this is just a quick thing to pay attention to. So we have two parameters, P1, P2, two people, and we just call age difference on P1, pass P2 as parameter, and we get, like I mentioned when we started, what do you get out of age difference? You get a negative, 0, or positive integer value. Okay, and that's how comparators work. Okay, the comparators object, the compare2 method from the comparable interface. That's what they do, right? They take two objects and then they say, if I return negative, this one comes after the other, and that's it. Yeah, question?
Would it be more easier if we just use the sort method that is provided by the collection instead of writing the whole lambda? Because in the end, we are defining our comparator and we are writing a full method in there.
Okay, so the question is, wouldn't it be easier to just use, the collection framework instead of injecting lambdas in there? Yes, it would be easier, and that's what we did before, right? But to make your class people, your class person, comparable, you only have two choices, okay, without lambda. One is to implement the comparable interface, which we reviewed briefly, and then the other one is to create comparator objects, okay? Well, this lambda here, this whole notation is not more complicated than creating a comparator object. And if you want to have different criteria to sort your list of people, you need to have comparator objects. So we just replaced an approach that is already a little bit more awkward, than just implementing comparable, with something that is no more awkward than using comparator objects. So if you want to compare this to something, this use of the lambda, you would compare it to creating your own comparator objects and passing them to the sort method, that has two parameters, okay? So it's not that much more. And the advantage of that is that now we open the door to streams, which means that we can do mapping operation, we can do filtering operation for free pretty much. We have access to all that API, which we didn't have access to with comparators, okay? So in terms of number of lines or character or whatever you want to use as metric, you know, we are not really far from comparator here, but we are much more flexible in terms of what we can do with the code. So that's the main advantage. And we're going to look at that like in the next couple of slides actually. So one thing that is interesting in this notation and this use of the by function is how it works with parameter routing, okay? So that's an extension, that's the last fourth case that I mentioned a few times already of parameter routing, okay? Well, here it comes. We have two parameters now in our lambda expression. So Java is going to be nice enough to understand that when you have something like this, okay, P1, P2, then by default, and it's completely arbitrary, right? By default, that means that you can use a method reference to the method edge difference. And if you do, then then Java is going to map P1 as being the target for invocation of the method. So it's going to call that method on that object, the object reference to by P1. And then it's going to be smart enough to say P2 is then the one parameter for my method. Okay? So again, that's not going to work with all by functions. It's not going to work with any code you want to write, but it's just the rule for the shortcut. If you want to use a shortcut, if you are doing something as simple as give me P1, P2, I call P1.methodName parameter P2, then you know you can replace that by the basic, method reference. All right. So that means that if we need to go back to that table of ours that we introduced a few lectures ago, I think. So here's the updated table for parameter routing. So the first three types of methods: static method of a class, instance method of a class, instance method of a static field out. So pretty much we call an instance method on an object that we specify in the method reference syntax. So all of those are the same than before. And then we added an extra row at the bottom of the table, which is for instance method of a class. Here is a class person that takes two parameters. Okay, so syntax of the lambda P1, P2, two parameters. You always apply the first parameter of the lambda as target of invocation, the second as parameter of your method. You simplify with this notation that we know already: name of the class, colon, colon, name of the method. P1 is the target, P2 is the parameter, and there we go. Yeah, question?
In case I have a range difference which takes two parameters, so will it be possible for me to pass the first as the target and the other two expressions?
Generally, you try to keep your lambda simple. Okay, theoretically, you could have lambda expression that have a ton of method, but in the case of sorted, for example, you have only one choice, which is pass a lambda expression that has two parameters. Okay, so your lambda needs to conform to pretty much the type of the parameter of the method you're trying to pass it to. Okay, so the problem with lambda expression is that when you start writing lambda expression, you start thinking a lambda expression is a function. I can pass function anywhere. So anytime a method is going to accept a lambda, I could write any sort of lambda and pass it. Okay. Well, with Java is a strongly typed language. So that's not going to fly, because underneath, and not so much actually underneath, but Java forces you, when you implement one of those methods that takes a lambda, to be really clear about what kind of lambda you expect. So you're going to say, I expect a predicate of string. Well, that's it. That means your lambda is going to take one parameter, which is a string, return a boolean. Okay? Or you say, I expect a function of string and integer. Okay, so you take a string, you return an integer, right? So, etc. So if you want two parameters, you're going to say, I expect a by function. By function is actually one of the functional interfaces, okay? So every time you use one of those methods, you have to remind yourself that it's been written somewhere, it's been defined, and when it was defined, the exact type of the parameter was set in stone. And for us, for lambda expression, the type of the parameter means functional interface. So that lambda needs to correspond, to match, to implement one of the defined functional interfaces in Java. Okay?
specific. I'm mapping a list. I'm collecting a new list based on getting a mean of two numbers and checking the first number in my list whether it's closer to the mean or it's closer to one of the extreme ends. So in that case, I might have two inputs to my function which can be called on a target. So in that case, if I want to create the lambda, will it take in the parameters? If I have three parameters, say P1, P2, and P3, and I have a function called check min max, and technically it is called P1.check min max, and the parameters it should take P2 and P3. Okay, so will this work?
So you're talking about a mapping operation here? Because most of the time when you talk about I'm going to make my lambda more complicated, what you need to do really is rethink how you are building your pipeline. So, for example, if you say that you need two parameters in your lambda free,
Parameters are probably going to be constant because I'm going to check my the target parameter based on the two constants. Or is it just preferable that I maintain those two constants in the function itself?
well, if 2 out of 3 of your parameters of your lambda are constants, then they really don't sound much like parameter, right?
Which it's kind of like trying to find a running algorithm.
No, but hold on. This is exactly what people use querying for, right? So if you say I have a 3-parameter lambda for whatever region, I'm not going to question that, okay? So you have a 3-parameter lambda somewhere that you need. Okay, fine. But then you tell me in this mapping operation or sorting or whatever, I always call that lambda with 2 parameter fixed. So what I would say is create a lambda that returns actually a lambda that is going to use, that, and this is getting weird, but that first lambda that has 3 parameter that you define, okay, but just calls it always with 2 parameter being fixed, okay?
You can call it P1, comma, then the lambda,
Mm-hmm.
then you can call it the
Yeah. Yeah. Okay, so watch out when we discuss about code like that, okay? That I hate discussing code verbally because it's like you are trying to picture your code in your mind and read it out loud to me, and I'm trying to read out loud to you and rebuild the code in my mind. I'm getting too old for that stuff, I guess. So, but if you want to come during office hour, and show me actual code, we can then work on it, okay? But from what I understand of your question, yeah, you would be able to either, simplify your lambda and have a few more steps, in your pipeline, or you'd be able to actually generate that lambda of yours as just a function, okay? Takes 1 parameter, returns a value, based on, pretty much querying it into the 3-parameter lambda, okay? So, I mean, maybe I'm missing something again. When I see the code, I'll be able to catch that hopefully. But right now, from your description, I don't see a need to go, to extend the interface here and go beyond the by function, okay? And generally, that's what I've seen in most of the code I've looked at. That's functional programming code in Java 8. It's like you never need to go that far. If you need to go that far, you can just work around it, by changing a little your pipeline. So, all right. So back on track. Yeah, we were done with the site. So that's parameter routing updated for our needs. Okay. So Java also covers that scenario. So everything we've done so far is nice, okay, but we still have only one lambda, one comparator. So even when we introduce the comparator objects, we talked about, okay, this is only good if you have multiple criteria, okay, so that you're not locked in when you implement the comparable interface. You're not locking your class to be only sortable by, for example, the person name. So now we're going to do the same thing here. We're going to move to example where, we want to start changing dynamically how we sort our collection of persons, okay, of people objects. So here's an example. Here we have this is actually, yes, this is opposite of what we were doing before. Okay, so same code. We just embed in the print people, the message, and then we put there directly the resulting collection. Okay, so everything is built on the fly and disposed of immediately. So same logic, people.stream.sorted.collect to list, except we don't assign that resulting list to any variable. So it's going to be immediately available for garbage collection after it has been passed and displayed by the print people method. Only thing we change really semantically is switch around P1 and P2, which means we cannot actually use the method reference notation anymore. Okay, we're not using the default order that the method reference notation is meant to help us achieve. So what we can do instead is we can assign lambda expressions to variables. Okay, so we can save somewhere in a variable named compare ascending. Okay, we can save that lambda expression that we used in the first example, and then we can create another variable here, compare descending. So these are the equivalent of our comparator objects, absolutely. Okay, and you assign that lambda, and as a matter of fact, the type of those variable, okay, the functional interface is comparator of person. What is a functional interface? It's actually an interface that features one method. Okay, that's the ID. When you say, I want a function, well, you're dealing with Java, so you need a class, right? You need an object. But that object has only one method inside of it, apply. And you call, name of your object, apply, and you can call your function like that. We've done it in the past, okay? Go back to the slide to refresh your memory. But when you have like something that allows you to compare objects, same thing. There's one method, test, okay? So that's what a functional interface at its core in Java 8 is. It's an interface that say, well, an object that is of a class that implements that functional interface is going to feature one method, and this is what that method is going to look like. This is what it's going to return. This is what it's going to take as parameter or parameters. Okay, so we are totally in that credo here. Yeah, questions.
What is going to be the parent of the comparator? I guess in the previous slides where we created multiple lambdas as per with the case when we were searching, we had the keyword function, and then we used the type and the final brackets. So can I pass this comparator to a function, to a data type, which is a type function?
Okay, so I'm not sure I follow your question. Your function is what is the superclass of comparator?
Superclass as in, I'm going to get the reference first and then
Okay, all right. Okay, we'll come back to that then. All right, so there are other things that we can do now that we have those lambdas stored in objects. Okay, we have a few methods here that we can use to modify them on the fly. So what we did in the previous slide, right? We swapped around P1 and P2. The effect of swapping around P1 and P2 was obviously that we swapped around, we inverted, the sorting order. That was the ID. Okay, wherever the edge difference between P1 and P2 was going to be positive, now it's going to be negative. And as far as comparators go, that's all we need to switch around the order of a sort, for example, or something like that. So we have a method called, appropriately enough, reversed. We can call reversed on a comparator. If you call reverse on the comparator, what you get is another comparator as result. Okay, so it's one of those, I modify a lambda, I get a new lambda. So you add a lambda in compare ascending. Now you're getting a lambda that is pretty much the sign inversion of the result of the other lambda that you define. Okay. So if I was writing this by hand, I could have said, I'm putting into compare descending on the last line a new lambda. This lambda is calling, p1.age difference, which is compare ascending, and then I'm simply putting a minus and returning that in front of that expression. Okay, so I inverted the sign, I inverted the sorting order. It's just a convenience method. And now that you have all of those lambdas in different variables, well, you recognize this code, right? This is yet again, for the third time, the same code here that we are using to display the result that we create on the fly. And we are just changing the lambda we pass. We reuse lambda, and then we can pass them as parameter. We can do all of those things that we do with any value in our Java programs. Okay, so that becomes very flexible. In the next slide deck, we're going to talk a little bit about design. Okay, in this case, we are like removing concerns. Okay, we have code here, and we are going to use a code that is very similar to that in the next slide deck. We have code where we wanted to isolate what made the decision of in what order we want to sort things. Okay, and we isolated it with a lambda. Okay, so same idea than when we introduced comparators. So we saw how to do the same sort in one direction, in another direction, and so on and so forth. Now what if I want to switch criteria for my sorting? That's not difficult. I just need to rewrite my lambda. Okay, so I put the lambda here directly in the call to sorted. I could have just put into a variable, pass that variable. So nothing new here. It has the same shape. Okay, this is still the same type of lambda I need to pass to sorted, but you can see that I can do things a little bit more fancy in my lambda. Like in this case, I have two calls to get name, okay, because I want to compare on name. So instead of having a method age difference that pretty much does the comparison on age for me already, I don't have anything yet in my class, but I can build it on the fly, right? I get a field, I get the field from the other object, and then I do whatever I have to do to compare them. In this case, I just call directly the compare to method because the data type of each of those fields, which is string, implements already the comparable class. Okay? And then last thing we're going to add in terms of convenience method. So we didn't talk about those mean and max terminal operation yet, okay? But every time you have a method that allows you to compare, okay, two objects, whether you have it already in the class, like here, so you use a method reference to reference it, or you have to write a lambda yourself, okay? No matter. When you can compare two objects, you can sort them. But you can also use the compare method, right, the comparison lambda, to go over your collection of objects and say, okay, I take the first one, the second one, I compare them. Well, the first one is bigger. Okay, so I keep that one. Remember the reduce operation, right? Take the first two, keep one of them, then take the next one, compare, keep only one of the two. Okay, keep one every time. Well, if we have something like person age difference, we can determine which one is older. If we can determine that, then we can go and reduce over our stream, right? And keep only, for example, the oldest of the two every time. Or keep the youngest of the two every time. So these are the two examples that are illustrated here, right? So whether you use mean or max, it depends on what you are trying to do, okay? You pass person age difference method reference, and then what you get is an optional. And that optional is going to be, in the first case, the youngest person in your collection. In the second case, the oldest person in your collection. All right. So now that you have an optional, you call on that optional of person. You call the if present method, which allows you to execute that lambda that is specified at the end here and here of each of the examples. You execute that lambda only if you got a result out of the stream. The only case where you would not get a result out of the stream is if your stream was already empty. Okay, so we are just protecting ourselves from that null pointer exception or all the junk that we have to do to handle, the potential for a null pointer. And then we just display, that lambda is easy. With optionals, it's always the same format. Okay, it takes a parameter, which is, well, if your optional triggers if present, that means that that parameter is, in this case, a person object, and you do something with that person object. Okay, so you had a question? Hold on. Let's go back to that at the end. I just don't want to break the flow and come back to, okay? But at the end of the class, we'll go back to your example, okay? Did you have a question too? Okay.
The previous slide.
Yeah? Let me go back to the previous slide. There we go.
We just have like a get name criteria for sorting. If suppose I need to first do with get name and first with the name and then first with suppose with the age. So what I have to do is I have to write a second sorted method which will take P1 and P2 and P1 dot
so
age.
We are going to get to that in a few slides, okay? So the question is, well, here in this case, you want me to use the age. In the previous example, I use the age. Here I'm using the name. What if I want to sort both using the name and the age, okay? We're going to get to that like in a few minutes. That's the next example pretty much, okay? And actually, I was not, is that the one? I think this is exactly coming right now or very close to. No, not yet, but very close. Okay. So in this example, we are starting to introduce the idea of multiple comparison. So we are going to first make it easier, syntactically speaking, okay? And then we're going to start doing what you were asking about, which is, combining multiple criteria to sort, for example, a collection. Okay, but first a little bit of syntax. So what we have at the top is what we've done so far. Okay, dot stream, dot sorted, and then pass my lambda to compare based on name. Okay, so what this is showing here is that we could say, all right, I want a by name. A by name is just the name of my method. Okay, that the name of my variable. The type of that variable is a functional interface, function of person and string. Takes a person, return a string, okay? And all it does is really call the accessor, okay? So we could keep in mind that even though I show you the explicit lambda here, we could use method references, okay? The idea is that, yes, that accessor is actually, implements a functional interface. It takes a person, it returns a string. The string is the name of that person. Yeah, that's exactly what we're talking about here, okay? That's a functional interface. But anyway, we write it here so that we can refer to it very easily, through this variable. But this is not an obligation. Well, if we want to sort, using the name criteria, well, here's a little bit of syntax simplification, okay? The streams allow us, the comparator and stream API allow us to do that very easily. We generate a stream, call sorted, and then we call comparing. Comparing is a method of the comparator class again, and we pass to that comparing method by name, which is a lambda, and that lambda is an accessor. So it's kind of a fancy way to say, I want to compare by name. So the choice of the variable is nice because, yeah, that's exactly how it reads. Comparing by name. Sort something, comparing by name. Or comparing by age. We could have a by age here that is just using the accessor to get the age out of a person, right? So the syntax is really nice, especially when you are careful about how you name your variables. And it kind of summarizes all of this. You don't have to write the lambda by hand. So there are two levels, right? The first level is, can I do it with a lambda? And then the second level is, once you get it to work with a lambda, then you can worry about, well, can I use method references? Okay, can I use method references? Can I actually, use like one of the helper method of the comparator class, collectors class, etc., to help me make my code even easier to read, even less, I need to reinvent the wheel, I need to reinvent a lambda to do a specific job. Okay, so as usual, this is the same advice that I give to my students when they first start programming, they take their first programming course with me. Okay. Don't optimize before it works, okay? And the joke in programming circle is that premature optimization is the root of all evil. We have many, many roots of evil, right? We have repeat yourself, premature optimization. Pretty much every time we realize after 10 years that we have been doing something wrong, we all label it like completely evil and we try to go as far as we can from it as a practice, okay? And then we do probably something equally as stupid, but that is the extreme opposite, and then it takes us another 5 years to realize that we should be probably in the middle, okay? But that's life, we're human. Okay, so here the thing is, you want to do this kind of optimization after you get it to work. So in the exam, concretely, that means that there are two types of questions. There are questions where I ask you to do something. So you get it to work with lambda, okay? Hopefully I ask you to do it with lambda. You get it to work, you make it clean, and once it works, you save your file, you make a copy on your desktop, okay? You don't touch it anymore. And if you have time, you keep working to improve, to add this kind of stuff. But hey, if something goes wrong and you're not capable to get that version of the code working for whatever reason, you forgot that you need to import, comparator, whatever, you run out of time, you can upload the version of the code that works. You get full credit, or close to, okay? Maybe you get a small point deduction because it could be better. But compare that to the alternative, right? You are trying to get this to work, and you overwrote your version that was working. Well, you run out of time. It's like the last 10 seconds. Maybe you don't upload anything, or maybe you upload something that doesn't compile, and then you lose many points, okay? Even worst case scenario than that, you start from the get-go wanting to do the perfect solution. You don't make yourself work iteratively, okay? One version after one version after one version, each of them working, each of them getting better. Now, you try to do this from the get-go, and for some reason you fail. You forgot the syntax, it's not your day, blah, blah, blah. You don't have anything intermediary that you can submit to the exam, Okay? So again, you lose a lot of points. These are like very basic advices, okay? This is, I give them in COP 2512, so I know you guys are like way past that, but I know also that at some of the exams I've seen like panic, I've seen, like a lot of stress. So I think that maybe not all of you are thinking about applying this programming, routine, this approach to development when you are taking the exam. Okay, and this kind of approach is very close to what you are going to most likely have to do when you work in a professional setting. Okay, a lot of companies nowadays, especially for small to medium project, they use extreme programming, they use agile methodology, they use Scrum as a project management methodology. So all of those revolve around this process that I described to you, and they have close to the same goals. You need to be able to deliver something every 2 weeks, for example. That works. All right, and if you mess up, you can always revert back to the previous version. Okay, so try to apply those techniques actually even when you try for exams. Okay, that's going to make your life a lot less stressful.
So,
yes.
Suppose I want to sort it in a descending order. Then how do I approach this comparing by name?
Well, you have different choices. Okay, so the question is, what if I want to sort by decreasing order? So we've seen that you can call reversed, okay, when you have like a comparator interface, or you can just write a lambda that calls by name, and reverses it and pass that one to comparing instead. So yeah, everything that we've seen so far that can be done, to change order is still applicable here.
Okay, and so isn't there a way that I'm creating another function person string and then I'm writing person lambda person dot get name. So isn't there a way of putting that person dot get name in place of by name in my when I'm using it?
Okay, I didn't follow your question. You want to modify the by name lambda? Is that what you're saying, or
instead of writing the variable name by name?
Yeah.
Can I write person arrow person dot get name directly in a way?
Well, yeah. Now, okay, there's a confusion here about parameter passing because you just asked me, instead of writing by name, can I pass actually a lambda there? Yes, the variable by name contains a value, right? So when you pass x to a method that expects an int, and the x value is 2 times 53, you can put 2 times 53 as a value inside of x, then pass x to your method, or you can pass directly to the method 2 times 53, right? You can pass the value directly or the variable holding the value. Here, by name is just a variable holding a value. The value happens to be an object of a class that implements a functional interface function, person, and string. Okay? But that's it. So you can use by name, you can bypass by name, no problem there. All right. So one of the things that's interesting, and we are getting closer to your original question, one of the things that is actually closer, I think we're going to hit your original question right here with this slide. One of the things that's interesting is you can say, okay, I have different criteria, and I'm going to store my criteria pretty much as the variables. So by name, by age, by salary, by employee ID. I could use all sort of stuff. Okay, let's think back about the employee class. So here I have by name, I have by age. All right. And then what we do is we are going to generate our stream again on the fly and eventually collect it to a list. And in between, we are going to combine those two criteria. We are going to say, I want to sort my stream. So first comparing by age. So again, I use the comparing method from the comparator class. Okay, so I'm comparing my elements by age, and then I'm calling another method here from the comparator class, which is then comparing. So I'm modifying the lambda that is returned by comparing. With the same kind of ID than when I call dot reversed. I don't need this. I can reinvent it. I can rewrite it in my lambda. I can do it by hand. Okay, it's just convenience. So when you have like an accessor for the age and accessor for the name, you can pass those accessors to comparing method and then add then comparing, which is going to just do function composition. Okay, so comparing by age returns a lambda that's going to do the comparison based on that field. Well, then comparing is going to take that lambda, it's going to wrap up in another lambda, and it's going to add a comparison by name. So it's exactly the concept of functional composition in mathematics, okay, but applied to programming. So it's pretty elegant. You can chain operation, okay, you write them, and more importantly, the code that you write, when you read it, exactly tells you what it's doing. Okay, some people refer to that as literate programming. The idea is that this is easier actually to debug and maintain and understand than most of the notation that we have used until now. Okay, so now we're going to kind of wrap up with the collect method. Yeah, question?
Previous slide.
Yeah, let me go back to the previous slide.
So you,
Yeah.
So you sorted with my like age and name, right? Like an integer and a string. So if we had a single word and we wanted to and if we had like 6 parameters, like 6 strings, and then we wanted to sort it based on the first letter and the second letter. Can we do that?
Okay, what do you mean by, let's say that I have 6 strings where in the collection?
Person comma string by name.
Yeah.
So, and we have like 6 parameters like Abby, Anna, or something like that.
No, hold on. When you say we have 6 parameters, you mean we have 6 person objects in the collection?
Like we have 6.
I mean, is that correct?
In the array.
Yeah. Okay. So.
Strings,
Okay.
like Abby, Anna, and some.
All right. So we have 6 people in our collection. Okay, got you.
So, like we have like 3 names which start with A, and 3 others which start with some other letter.
Mm-hmm.
So we sorted based on the first letter and the second letter. Can we do that?
But that's what lexicographic ordering means. So the question is, if we have 6 names in the collection and 3 of them start with A, so the next 3 starts with B, can we sort on the first?
Based on the first letter and the second letter.
Only the first letter and second letter. You want to sort them only by first and second letter?
Yeah.
Then you have to write your own lambdas. Because by default here what we are doing underneath is we are comparing strings, so we are using the compare to method of the class string. We are using the natural order of strings, which means that yes, we are comparing on the first 2 characters, but then we are going to the third character if there is equality. So if you guarantee me that in your collection, we don't have situation where the first 2 characters are the same and then the third character in a name is different, in 2 different persons, then we don't care. Okay, but if you insist about it's really important for my application that I compare only on the first 2 characters, so somebody called ABC is the same as somebody called ABD, then you need to write your customized code. You're not relying on the string natural order.
So it automatically takes it if the first letter is the same. Like it automatically takes the second letter into consideration if the first.
Yeah, that's lexicographic sorting. So hold on. Let me see if I can try to attack this from another angle. What I'm saying here when I say comparing by age, then comparing by name, is that if 2 people have the same age, okay, then I am not going to keep them in the same order that they were in the original collection. That's the property that we called stable sorting in the past, okay? And we know that the sorting algorithm in the Java collection framework are stable. So instead, what I'm saying is that if 2 people have the same age, then I'm going to reorder them in my resulting collection based on their name. Okay? So it's like 2-step sorting. Does that make more sense? Is that okay? All right. All right. So I keep losing my mouse today. Sorry about that. There we go. Got it back. So now we are going to go back to collect. Okay, and this is the last time we are going to revisit collect. Hopefully we are going to introduce more details here. So as usual, we start with the always. I mean, this is not the old always. I mean, we are still using streams and lambdas, so it's not like imperative programming, but it's still something that we are going to improve upon, I should say. So we have a list of person, and we declared as variable older than 20 in red over there. To be a list of person, we create it as an empty collection. All right. And then we stream from people. And we're going to filter, so the name older than 20, already gave you an idea of what we want to do here. We're going to stream all the individual from the people collection. Then we're going to filter. We provide a method, Lambda, to do the filtering. So given a person, I'm going to keep that person if the age is greater than 20. And then for each of the resulting person, I'm going to take that person that has been filtered in, and then take my variable older than 20 and call add on it and add this person. Okay, so this is how we do things before collect. All right, we build our own collection on the fly, initialize it to empty, keep adding every element that is filtered, and then display it, use it. And this is what we get in our case. Okay, so the format of the display is standard. Okay, we are formatting pretty much a list of people, and then for each person that is kept in the list, we're using the toString method that we implemented at the beginning of the session. So we have the name of the person dash the age, and then comma the next object. So these are the 3 people in my collection that match that criterion. So we can use collect to do that. That was the point that we said, we stated when we introduced the collect method, but we didn't use this version of the collect method. This version of the collect method is pretty much a 3-step process, okay? And this is the long detailed form of the collect method. This is a most customizable version of the collect method. What we have is 3 parameters. In this case, we could pass lambdas, right? We are passing method reference because we're just referring to method that already exists. No point in wrapping them around a new lambda. So what does collect care about? It cares about, first, how am I going to build the resulting container that you want me to collect things into? Okay? So instead of us creating our empty collection at the beginning, we let collect do that. Collect needs to have a reference to a constructor. So reference to constructors are always name of the class, : new. No matter what the name of the class is, that's how you refer to the constructor. It's kind of a little exception to the syntax here in the notation, okay? So this is going to be used by collect to start by creating a collection of the appropriate type. And then we have array list : add. That's the reference to the method on that collection. So I wanted to create a new array list, so I'm going to keep giving method that work on array list, okay? So this is a method for that collection that allows collect to add a single element. So you configure collect to say this is how you're going to add an element. Collect always do the same thing. Create an empty collection, add every element, and then merge, like 2 partial results from the collect operation with one another. So these are our 3 steps. The first step being, how do I take one of my partial result and merge it with another partial result? Well, in the case of array list, we have the add all method that allows us to add all the elements from an array list to another array list and obtain a new array list. Okay, that's it. So that's the most complicated version of collect. So you might find, one day you might find yourself using a custom collection, a class that is, for example, all my employees, and that, as the name implies, sort of is a database of all your employees, and you are going to want to collect into that. So not a list, not an array list, not anything that is already, covered in the slide. Don't panic, okay? The idea is the same. You have a collection class that you wrote yourself. You have to have a way to create an object, an empty collection of, of that type. That's going to be your first method reference. Then you need something to add one element. So if it's a collection of person, add one person to your custom collection. And then you'll have to think about making sure you have a way to merge together 2 such collections. If you provide that in your custom collection, employee database, whatever you want to call it, then you can even collect directly to that custom collection. Okay, there's no magic. It's not restricted to the types that are available in the Java collection framework. And this is what you're already used to, which is a short form, okay? You want to do that, you want to know that you can do that for all of your exceptional needs. Okay, every time you have something that's not standard. But what did we do until now? Until we even discovered that there is a 3-parameter version of the collect method. Well, we just did basic stuff. Like I want to collect to a map, to a set, to a list, okay, or I want even to join, into a string. Well, all of those thing to list, to set, to map, joining, all of those methods were method from the collectors class. And we used, actually, when we did a collect operation, a collect terminal operation, we used collectors.toList, or for short toList if we had the proper import, okay? Well, that did exactly what we described for an array list. But we have this available for all sorts of basic data types, that are already included for free in the Java collection framework.
So,
Yep.
in the previous slide, we used array list, column new.
Yep.
Yeah, so what if I need to save this array list from array list to add on? I need to save this in a separate variable, and then I'm going to later just use collect, and in the bracket I'm going to pass that variable.
Okay, so you don't want to save that array list that we are building in the slide to any variables before the collect is done, because then there's no point in doing a collect.
No, okay.
Do you see what I mean?
I just need to verify that I convey to you the correct thing. Array list column new, comma array list column add, comma array list column add on. I need to save this. I'm saving just this parameter in a separate variable, like the way I'm storing a lambda, and then I'm just calling the variable name.
So how do you save three parameters in a variable? I'm not following you. What do you mean by I'm saving? What you're saying is I'm going to save the array list : new, array list : add, and array list : add all in one variable.
No, okay, in three variables.
In three variables, okay. And
What would be the return type of that? Like, how would I define that variable? What would be its data type?
okay, you can put method reference in variables, no problem. But then you ask me what is the return type of what?
Of the array list column new.
I'm not following you. The array list : new is a constructor from the class array list. What is the return type of a constructor? Always an object of that class, right? So I'm not sure I fully understood your question.
Understood the type of the lambda. What would be the type of the lambda to which we should assign array list : new?
Okay, so if you have array list : new and you want to look at it as a type for lambda, then what is it? It's a function, right? It's a function. Actually, it's not even a function. It's what is it called? A producer. A producer means that it's a function that takes no parameter. Okay, in this case, we assume we have a no argument constructor, and it returns a type. So in this case, it would be a producer of, what are we trying to produce? We are trying to produce an array list of person. Does that make sense? Is that actually where your question? Okay, all right. Thank you for clarifying the question. We'll get to the bottom of it. It will take all of us, but we'll get to the bottom of it. Okay. Yeah.
The slide second array list column add. It's actually a function of two. It accepts, like, it's instance method. Add is instance method, and it accepts one argument. So we use this notation, like referring to previous routing mechanics, to accept two parameters, like as I understood, accumulator, yes, and new element. So it's true, yeah.
Yeah. So the remark was, what about array list add? And array list add is a method reference, but you're right that method reference is going to be parameter routed, so that we take actually two parameters, which is one, the object to which we want to add something. Okay, so the reference to the array list collection, existing array list collection to which we want to add something, and then in the add method, we are going to pass a parameter, and that parameter is going to be what we want to add. So it's going to be a person object.
Yeah.
So that means that this is actually, pretty much a bifunction there.
Yeah, and add all it's a static method from the array list.
No, add all is not a static method from a release. Add all just allows you to do exactly the same thing. You have two collections, call them P1, P2. Right, P1.addAll P2 means you take all the elements in collection P2, you add them to the collection P1. So the first one is kind of a little special, it's a constructor, okay? The second and the third one are more traditional lambda. If we wanted to write this as lambda, we would take two parameters and apply add or add all to the first parameter, and then pass as parameter to that method the second lambda parameter. Okay? Let me know if I'm going too fast, okay? Just like stop, pause, and rewind. We'll get to the bottom of your questions. All right. So what do we have here? We have this long form, we have this short form. So this collectors.toList, that one I don't remember. What was the data type returned here? Probably a collector object. But that encapsulates those three parameters. Okay. So the other way is just a way to detail. I have 3 different steps, and they are going to be different because whatever. Because I'm using a weird custom collection, something like that. Okay. But then at the end of the day, if I'm using a basic collection from the Java collection framework, I have shortcuts notation. So again, yes, you need to know that. You need to know that so that you can read it in other people's code, so that you can write better code, okay? But if you have a doubt, start with whatever is the simplest approach in your mind. Okay, some of you are going to go directly there. That's fine. That's actually a good idea if you're using a standard collection, okay? Some of you are going to think in terms of the 3 parameter and then, no pun intended, but map it to the simpler version. That's fine. Start with what is easy and clear for you, get it to work, and then optimize and then refactor. Right? Okay, and there are a few other things that we can do with this kind of syntax that are actually pretty interesting as well. So we still have our people collection. Okay, so the collection at the base of our example here didn't change. We still stream it. We still collect it, okay? And we keep exploring the available collectors that are already written for us, prepared for us, okay? In this case, we are using the grouping by collector. So we're going to use the grouping by, method of the collectors class. We pass to it a method reference. So we could pass here, by age. All right, we could pass the variable that contain, that lambda that extracts the age. We could pass the lambda itself, but like I told you at the beginning, those lambda that we use for by age and by name, they are just actually the accessors, and we define them in the class. So we can say directly, I'm going to pass you a method reference to the accessor in the class. Okay, so three ways to pass things here: the lambda directly. The lambda, store it in a variable, then pass the variable, or the method reference directly. Okay? All right, so here we're going for the lazy and most readable version, which is the method reference. Fine. So what do we mean when we say, I want to take all of the people in the collection, and I want to collect with a grouping by approach? Well, the end result of this, let's look at the bottom of the slide, okay? The end result of this, when you display it, is not a list anymore. Okay, so you went from a list of something collection to something else. This is actually a map. So the default way we display maps is with those curly braces. Okay, and you know how maps are working, right? It's a key and a value pair. So we have a bunch of key value pair in no particular order. So if you look at the display, the key here is an age. So we are saying out of my collection people, there are people there are at least one person that is 35 years old. Well, that one person is Greg. And you can double check here because when we display, the object with toString, you can see the name is Greg and you can see the age is 35. Okay? And then, next element of my map. There is one person that is 20 years old. John. John is 20. Okay. And then there are 2 people that are 21. This is where it gets interesting. There are 2 people that are 21. So then you can notice here the square bracket mean we talked about list, right? So this was a list of one person, Greg, a list of one person, John, and here it comes a list of 2 persons, Sarah and Jane. Okay, both of them are 21. So this is what the grouping by did for us. It took whatever was coming in the stream, okay? It used the age as a criteria. So for every single different ages that is available in my stream, I'm going to have an entry in a map. And the key for that entry will be the age. And then I'm going to look at how many people, how many different person objects in my stream have that same age, and I'm going to put them in a list a list of person. And that's going to be the value in the map for that key that was the age. So for the age of 35, I have a list of one person. Age of 20, list of one person. Age of 21, list of two person objects. Okay? That's it. So the only thing we have to go back on here to clarify is the type for people by age. Okay? And that's kind of what sets Java, again, apart from other functional programming languages that are dynamic. The other functional programming languages are also going to use internally that concept of type, I mean, except if they have a different type paradigm, like duck typing, whatever. But here we have to make it explicit. We have to write it explicitly. So some people refer to that as intentional programming. The idea that you don't just want to write code, and when you run the code, it does what you expect. Yeah, that's great. You know, we all love that, of course. It beats the alternative. But the idea is that you don't want things to happen without fully understanding what happens. And this is a subjective matter, okay? You could argue, you know, in many situations, you could argue, well, yeah, but this is a waste of time in this situation. True. You are never going to find me claiming that one tool is a silver bullet. Okay, I much prefer understanding what each tool is good at and bad at, and then when comes a task my way, I can choose the tool most appropriate to the task. Okay, and I encourage you to do that. But so put that into context. Okay, but here we are stuck with Java, so we need to be completely explicit about this is exactly what I expect to come into that variable. This is what I expect my result to be. Once you say that to the compiler, then the compiler double check for you that the result is appropriate. So the notation, that's going to bring us back to the days of when we studied generics, okay, that I'm sure everybody enjoyed thoroughly. So we have a map as result. That's fine. A map of what? The key is an integer value. Okay, so if we get an int, no problem, we auto box to integer, you know that. And then the value for each key is going to be a list of person. So that makes sense. If you understand the ID behind grouping by, you look at the output, you make sense of the output, then you go back to the type and you say, well, yeah, that makes sense. Okay. The difficulty is if you start reading here and you start with that and you're like, oh, great. You know, I have like nested generics here and then what? People by age, etc. No. So learn to jump through the code when you try to understand it. Okay. So we have a neat feature here. We can do nice groupings there without having to introduce much more syntax. Well, it doesn't stop there. The grouping, there are different versions of grouping. Okay, so we saw the grouping by that takes one parameter, and it's pretty much intuitive. Okay, but then we have a grouping by that takes multiple parameters, and the second parameter allows you to apply different processing steps. So it's kind of like what we did in the stream, okay? Several intermediary steps, right? And then a terminal step. Well, here we are kind of saying the same thing. What is the idea of grouping? The idea of grouping is that you specify as first parameter here and only parameter in the previous slide, you specify what you want to group by. So we didn't change that criterion. We still want to group by age. So if we jump at the bottom and we look at the output is going to be people grouped by age, and you see 35 is the key in the map. Then I have a list here, square brackets, right? And the list has only Greg. If I go back to the previous slide, the only notable difference was that my list here used the toString from the class person, which displayed the name and the age. So obviously here we want to do something about, you know, what is the end result? Is it a person object, or is it just a part of a person object? In this case, you know, just extract for me the string that represents the name. So that's what we want to do. We want to say, I want to do all this stuff, people.stream.filter, .map, whatever, okay? 10,000 intermediary operation, and then I want to collect group by age, but hold on, don't give me the person objects. Do something else. What is it called when you try to take a stream of person objects and you try to, for example, generate an int stream of their age? That's called a mapping, right? So appropriately enough, the method we are going to use here is mapping. Personally, I would have much preferred it if we had only one syntax, one map operation, you know, that we can use everywhere. Okay? That's the thing you have to be careful about. there is a dot map to obj, map to int, etc. And then there is the mapping method right there inside the grouping by syntax. Okay, the intent is the same, the concept is the same. Okay, but we don't just use a stream map. Here. So what is this? Let me just finish this and I'll jump into your question. Okay, what is this mapping doing? Well, we know that when we group by age, okay, we know from the previous slide that we're going to get a list of those object person, okay? So now what we are saying is, yeah, we still get a list, okay? But instead of a list of person object, I'm going to take that list of person object. I'm going to map the operation person : get name. So I'm applying get name on each of those objects, which returns to me a string. So I'm getting kind of like the idea of a stream of strings here coming out of this. And then I'm going to list it, which brings two things together, right? A map operation, so that mapping method does two things. A map operation, and then a collect operation. Okay, again, this is, kind of like wonky, that we do the same thing we did before, but we have a new syntax and it's not the same data type. So it's a little bit confusing, okay? Just look at it as a recipe for now, because this is really what it is, okay? We could generate streams of streams to try to solve that problem. We could do everything by hand. So all we are talking about in this lecture is, okay, what are the shortcuts that are available and what situation do those shortcuts apply to, okay? So in this case, if you want to group by, use grouping by if it's a trivial grouping by. And then if you want, in addition, to not get the object but get something simple that can be derived from the object, then here's a syntax to do that. So I have two questions in the queue. You were first, so go ahead.
Yeah, you partially answered the question. So mapping is the method from the collectors too.
Yeah.
And you said that it collects the list.
Yeah. So it's really a shortcut. For the recording, you were asking, is mapping a method from collectors? Yeah, it's not the same, dot map operation that is an intermediary stream or in stream or stuff like that, operation. In this case, we are really relying on an implementation of a class. And how does this implementation work? For all I know, it could generate a stream. It could do all at once. I just don't care. Okay, I care about the ability to invoke that shortcut when I have a trivial operation for which the Java developer already, implemented such a shortcut method. Okay. Yeah, you had a question too?
You could have used toCollect, right? Dot collect of toList.
Here?
Yeah.
Yes. Instead of writing toList, you could write collectors.toList. That's actually one weakness of the slides. I don't know if next time I'm going to fix it, or if it's something that I should actually just, explain like this. But I tend to use a shortcut notation here that assumes a proper import, okay? So you know that when you do like static import or regular import, you don't have to carry around, the name of the class all the time, right? So that's what's happening here. toList is not a magical method that's falling from the sky. It's a toList static method from the collectors class, okay? So if I wanted to write this extensive, like full and unambiguous, I would have written collectors.toList. But if I do an import, I can just write toList, which in practice, that's what I would do. I'm pretty sure this is what you guys are going to end up doing, because you're going to get tired of typing always collectors.toList, collectors.tomap, etc. But that makes the slide slightly less readable. So is that the problem that you had with this, or?
I just want to know if it's the same.
Yeah. Yeah, it is. It is the same than we have used before. It's a parameter to mapping, right? The same way that person.getName is still a lambda that represents a functional interface, that represents pretty much an accessor for a field. Okay? Question?
Like in the earlier example, we used to specify collect and bracket collector.toList, that we would be expecting a list from the collector.
Mm-hmm.
So in this example, we are not specifying collectors.tomap anywhere.
No. So the remark is, in this case, we use collectors to list because we expect a list somewhere. Okay, and the somewhere is, if you look at the last line, it's for each value, you know, in our map. But we never specify collectors.toMap anywhere. No, we didn't specify it explicitly because we use the grouping by method. And the grouping by method will always return to you a map. Okay, that's the idea of grouping by. Okay, you want to group your employee by, I don't know, by first name, last name. I mean, that's kind of a weird example, but by department where they work, for example, is a better example. Well, you are going to get a map where the key is the department name and the value is a list of, you know, employees that are in that department. Last example, and it's not a lie, actually, that's the last slide for the slide deck. So oddly enough, that goes kind of like, I had a question sooner, right, where you were asking, no, I don't remember who was asking that. Who was asking about, like, I want to sort only on first and second? Yeah, that was you. Okay, well, we are getting closer to that, but not quite, you know, like the kind of the exceptional case you were asking about, okay? But in this case, we are going to try to group things by the first character of the name. Okay, so we are going to use a grouping by, we're going to get a map. The key of the map is the first character of the name, and then we are going to get a list of individuals that have that character as first character of their name. All right. So again, this is just to you know, illustrate everything you can, not everything, but the most interesting or obvious things you can do with that API. Okay. So we have the same kind of stuff here at the core. People.toStream, all right, .collect, grouping by. This time, what we want to group by is only the first character of the name. So we have to provide something that is not a method reference. We provide our Lambda, give me a person, I call getName on it, and I get the first character of that name. Okay? And then the same way that we saw, like, there's those kind of collect operation, you know, map and collect operation together under the label mapping in the previous slide, we have another method here called reducing that we can call. And guess what it's going to do? It's going to apply a reduction operator. Okay? In this case, what we apply as a reduction operator is already implemented for us. It's a binary operator, so we use from the class binary operator the maxBy method, okay, which is going to allow us to take two elements of the stream and return only the one that maximizes whatever this Lambda does here by age. Okay, if I lose audio right now, this is just my fault because I tugged on the wire like crazy. So that's just, again, it's a very readable syntax. The only way to know about those things is to have like good shortcut, good links, bookmarks to the documentation. Okay, you are not expected to memorize all of those. Okay, the idea is you need to know where to find them in the documentation. That's all. All right. So in this case, I'm going to reduce that stream, and I'm going to reduce it and get a list out of it, and it's going to give me the one person, okay, that matches that criteria. So that has that is oldest, that has the highest age. And of course, the result of that is actually an optional. Okay. So if I go back up here and I start decrypting, you know, all the data type, the oldest person of each letter is going to be a map that takes a character and then an optional of person. All right. So that's my end result here. And the by age method that I use here, well, that you're already familiar with. It's a comparator of person. Okay, and I obtain it just by calling the comparing method from the comparator class static method and passing the accessor to the field that I want to use for the comparison. Question?
Yeah. So like in this we specified optional of person, so in the output it is showing me optional of Sarah 21.
Yeah.
And you are specifying list of person. In that case, it was not specifying as list of Sarah and 21. It was just specifying as and Sarah 21, right? In the previous slide.
Yes,
So
that's correct.
So why is it printing the optional and why not the list like?
Okay, so we went from a list to an optional here because we changed actually the operation that we were applying here. Okay, in the previous slide, we were using an operation here instead of reducing that we knew was going to give us a list. Okay. In this case, we are using the reducing operation, and the reducing operation, just like the reduce operation in streams, returns always an optional. because you don't know what the nature of your reduction is going to be. It's possible that your reduction returns nothing. You could not process the code, the lambda that you pass as parameter, and get a result out of it. So that's why it's an optional. So we have two differences between this slide and the previous one at the level of what the values in the map are going to be. The previous slide, they were a list. In this slide, they are an optional of person. Okay? All good? Yeah, question?
Optional, so we will not have empty optional because group in by always will return the group with at least one element, yes? So optional will be always...
True. Okay, so the remark is, in this case, we don't really care about the optional, and actually we don't even do anything with the fact that the result is an optional. You're right. Because grouping by is going to create an entry in the map only if there is, a key for which we have a result. We have like one or more individual. So in this case, if you reduce to nothing, well, actually, yeah, in this case, if we reduce to nothing, it doesn't make sense. I agree. But keep your mind open to, I don't know what my reduction is going to be. My reduction could be, for example, I'm going to look up this person's names on Wikipedia, and if I don't find an entry for them, then I don't keep them. Okay? So yes, you could still have, in this example, you're absolutely right, the optional is kind of overkill. But in the general case, generally speaking, we could have a reduce operation that ends up returning an empty optional. So that's why the return type of reduce operation is optional still. Does that make sense? Okay. I'm going to stop the recording for the session, but I'll still be around. So if you have questions, feel free to ask, okay?